Okay, we have rational exponents and properties of exponents kind of all coming together in this particular lesson. So let's write down our rules here. So if I have x to the m times x to the n, the bases have to be exactly the same. If the bases are the same, then I'm going to add the exponents. If I have x to the m and I'm raising it to the n power, then I'm going to multiply the exponents, m times n. And if I have x to the m over x to the n, I get x to the m minus n. If this is negative, it's going to go into the denominator. If it's positive, it's going to stay in the numerator. So let's look at a couple of examples of each of these. So let's take a look at one that looks like our first one here. And we're going to do this one. So example number 1. If I have 4x to the 3/2 power times 3x to the 1/4 power. Now, if these were in radical form, I would have a square root and a fourth root. And I can't combine them if they're in radical form. However, if they're in exponent form, I can. So I'm going to go ahead and multiply my numbers. So I have 4 times 3 is 12. And then I have x to the 3/2 power. And notice my bases are the same. So if the bases are the same and I'm multiplying, I can add the exponents. So it would be 3/2 plus 1/4. Well, if I have 3/2 plus 1/4, the common denominator is 4. I need to multiply by 2. So I get 6/4 plus 1/4 gives me 5/4. So it's 12x to the 5/4. Now it depends on what your answer looks like. We could write it like this. We could also write it as 12, the 4th root of x to the 5th. But we know that that's not complete. We know that one set of 4 x's is going to come out. So it would be 12x and then the 5th root of x, because I'd have x, 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 x. 4 of them come out. It's an odd root. Oh, no, it's not. It's a 4. My bad. That should be a 4. It's an even root. So since it's an even root, and this is an odd power, I need absolute value marks. So it could be written, your answer could be written as rational exponents, or your answer could be written in radical form. If it is written in radical form, it would be reduced like this. So now let's look at another example. Example number 2. What if I had something that looked like this? I have x to the 1/3 power, all raised to the 4/3. Well, this is just like our power rule right here. So we're going to multiply our exponents. So we have x to the 1/3 times 4/3. So I really can't cancel anything, and so I get x to the 4/9. If I were looking at this problem in radical form, it would basically be saying the cubed root of x. Hold on. This problem in radical form would actually be the cubed root of x. But then I'm going to take the cubed root of that again, and I'm going to raise that to the 4th power. So that is really what this problem is saying. So if I were to take this and put it in exponent form, I can easily figure out that that's going to equal x to the 4th, the 9th root of x to the 4th. So either of these would be equivalent, and these two problems are equivalent. So that's our power rule. So now let's take a look at our let's look at an example that has one that has a quotient rule. Oh, let's do this one. What if I have the square root of x to the 5th divided by the 4th root of x to the 3rd? All right, so right now I have different radicals. I have a square root and a 4th root, so I can't do anything with it right now, but I'm going to rewrite it as in exponential form. So this would be x to the 5/2 power. It's a 2 because that's the root, that's the index, and the power on the x is a 5. And I'm going to divide that by, well, I have x to the 3/4 because this is my index. Index is always my denominator, and I have x to the 3rd. I have the same bases, so if I have the same bases, I'm going to use this rule. Same base, I subtract the exponent in the numerator minus the exponent in the denominator. So this is going to equal x to the 5/2 minus 3/4. Alright, so 5/2 minus 3/4, the common denominator would be 4. And this would give me 10/4 minus 3/4 equals x to the 7/4. Alright, so x to the 7/4, that is, 7/4 is positive, so it's just going to stay up top in our numerator. So it could be written like this. This could be our answer. There's one way to write it. If I want to write it in radical form, that answer would look like the 4th root of x to the 7th, but that's not most reduced. So that would be 7x's, 2, 3, 4, 5, 6, 7. I'm going to circle 4 of those x's, and they're going to come out. So I'd have x, and then I'd have the 4th root of x to the 3rd. Now, even root, so it would have to have absolute value marks on the x. So here is another way that I could write my answer. So here is your quotient property, you have your power property, and you have your product property. All right, we're going to do one question that kind of brings that all together. Let's look at this one. Let's look. Most of these are going to just be one step or another. So it doesn't look like we need to take it that far. Here's a mixed one. Let's throw this one in, and then we'll be done. This really isn't, this is really just mixed radicals and properties with exponents, but let's go ahead and throw that in there. We have x to the 1/2, y raised to the 3rd power. So it does have some of those pieces in it. This first, let's write this as x, y to the 1/4. And let's go ahead and pass this guy through. So 3 times 1/2 is x to the 3/2. And then we have y to the 3rd. So let's go ahead and pass this through. I have x to the 1/4, y to the 1/4, x to the 3/2, y to the 3rd. I have same bases, so back to our, if we have the same base, we add the exponents. So I'm going to take 1/4 plus 3/2. Common denominator would be 4. So I'd end up with, looks looks like 7/4, so I'd have x to the 7/4, y to the, I've got 1/4 plus 3, or 3 over 1. I can't write it in mixed numbers. We can't do that. So it looks like my common denominator is going to be a 4. So I'd have 1/4 plus 12/4 gives me 13/4. So we have a common, if I were to write this in radical form, my common radical is the 4th root of x to the 7th, y to the 13th. So this is one answer possibility. Another answer possibility, this isn't most reduced yet, so I have x to the 4th, x to the 3rd, y to the 4th, y to the 4th, y to the 4th, and y. I kind of divided it basically in sets of 4. This guy's going to come out. These guys are going to come out. And so I'm left with the 4th root of x to the 3rd y. And then I have an x and a y cubed. Even power here, so I need absolute value marks on my x and my y. So that kind of puts it all together.